Hey listeners, welcome back to the second episode of season 2 of What the Perf podcast. This is your host Mrinal. In today's episode, I and Mohan Manoharan have a freewheeling chat about what DevOps transformation means, how performance engineers can adapt to it. Mohan also talks about the three ways and the ideals discussed in the books, the Phoenix project and the Unicorn project. The discussion was so engrossing it went on for a little more than an hour, and Mohan has really laid out some great insights, and I don't want any of our listeners to miss out on them. So I have skipped the news and what the crash sections for this episode. Go ahead and enjoy the episode. Hey Mohan, welcome to What the Puff podcast. Uh, it's been a long time we've been planning to do this episode. Finally, we get the time to do it now. So welcome to once again, welcome to What the Puff podcast.
Thanks, Pranal. Uh, I'm really honored to have been invited to this. I really enjoyed listening to your previous podcast.
So let's start today's episode. Mohan, can you give our listeners a brief introduction about yourself?
Sure, Pranal. Okay. Hey, folks. I'm Mohan Manoharan. I'm a technical advisor with FedEx Express International Europe. I work in the Netherlands. I've been living there for 5+ years now. Uh, my professional journey it started with Infosys in 2010. I initially started off as a manual tester for a project where I worked for a couple of months, and for the same project, I started doing some automation testing. And 2 months down the lane, I became a performance tester for the same project. So that's how I started doing automation and performance testing together. So
Wow.
since then, I've always been doing both automation and performance testing together, at least for a few years. So at least for the next 3-4 years, I was doing both automation and performance testing together. So I got some really good opportunities to work on good technologies, good toolings, and most importantly, I got the freedom to explore whatever I wanted to do, and I wasn't restricted at my job due to some good mentors I had and some really good managers too. So I think around 2014, I moved to the UK for logistics client of Infosys, and again, so since then I've been playing a major performance related role. But recently, after joining FedEx, I've been looking into test automation, service visualization, continuous testing, and performance testing as well. So my role is not purely uh, mandated for performance testing anymore. So that's about it, Mrinal. So I think I've given a quick overview.
Yeah, I mean, the breadth of fields or knowledge you have covered in your 10 plus years of career is really amazing. So, as you said, you got into performance space by chance, can we say, or how was it?
Yeah, so I actually wanted to be a developer.
Mm-hmm.
And when I was assigned to manual testing in Infosys, I actually walked up to my delivery manager, who is managing 200 plus people. And I asked her, can you assign me to something else? I'm a 5 pointer in my Infosys training, and I'm a gold medalist in my graduation. So I was trying to brag about myself and my development skills. And I told her, can you assign me to something else? She looks up at me and says, first try and do manual testing well, then let me think about it. so, so it took me a couple of months, and I think at least I must have did something right. So she said, okay, go ahead and do test automation. It's I think it involves some level of coding, so you'll enjoy it. And I started doing test automation, and quickly I found out test automation is uh, it's actually interesting, but then it's not too complex. So I actually wanted to do something more as well, and then that's when I got to know we have a performance testing role coming up as well, and I was glad to jump on it.
Mhm.
What interested me so much about performance is you need to understand the application behavior, you need to understand the application architecture. So, and especially if you want to say do tuning or if you want to do monitoring, so there are a lot of technical components involved. So I find performance testing as one of the most complex items in the whole testing space,
Mhm.
especially considering you will have to even look into the application code. So
Yeah.
when you start reading code, you'll realize that you enjoy it much more than writing code. So that's what I find. So I find it really interesting to start reading into code written by developers and help them tune it
Mm.
and say understanding architectures and setting up monitoring for those, understanding what could be the potential bottleneck in a system and trying to target performance just to uncover that. So those are the kind of things that I found really interesting, and that's how I started venturing more and more into performance testing and started doing less of test automation.
Good, good. Because of your delivery manager's decision, now we have a great performance engineer as part of our community.
Yeah.
So, Mohan, we often hear uh, in performance community, we often hear the words DevOps transformation. We are coming
Mhm.
across those two words very much on LinkedIn and many other places, right? What exactly
Mm.
does DevOps transformation mean? Could you help our listeners understand what exactly those words mean?
So, during one of my early Infosys projects, I actually got a chance to work on a pure agile project. So basically, the team it was a French team, and they actually wanted to deliver their system to production at least once every 2 weeks.
Hmm.
Having worked in a lot of waterfall projects before that, I was really surprised that they want to try and deliver a software to production every 2 weeks, that to a working software in a good quality. So I was really surprised.
Hmm.
And that's when I started reading up about continuous integration and continuous deployment and more on agile. So that's when I got to know about DevOps for the first time. So this was in 2012, 2013,
Hmm.
and DevOps was a very new terminology. I think it was coined only in 2009 or 2010, and it was a pretty new terminology. And even I found delivering a software once every 2 weeks to production was much more challenging. And I remember one of the first DevOps related videos I saw was, uh, I think it was a video on how Flickr has been deploying 10 plus times a day. And
Hmm.
this was in 2012 or 2013. So I was
Yeah.
really surprised.
It was
And
by John Allspa, right?
yeah, the also one, yeah.
Yeah.
So I was really surprised when you think about it. Even now, a lot of large organizations and a lot of even smaller organizations, the kind of complexity they built into their software development lifecycle and the delivery process, it takes months. Uh, Say many large organizations I know actually has say 2 or 3 release cycles per year, and they try to deploy applications into production. Because one of the things is they're worried about reliability.
Yeah.
Of course, they may think that because of the brittle uh, say delivery process, or even because of the brittle applications, the more often you deploy, the more often the chances are there it could fail. So they may think, okay, it's better to just have the working application in production as is instead of tinkering with it frequently. So
Yeah.
that's understandable. But then what DevOps proposes is you have an idea and you want to get it to customer, you need to do it as soon as possible. So
Hmm.
that's the whole principle of DevOps is faster time to market to the consumer. So any business, the whole point of business is adding value to the customer or the client. And so what DevOps proposes is it's actually it's a very complex or vast area which encompasses a lot of topics. So the foremost one is one of the most basic one, but also one of the most challenging ones anywhere. It's the culture change. So culture is one of the most basic principles of DevOps. And what does culture change? It changes the people. It changes the process. It changes the tools. So it influences all these three pillars of any organization. So say generally, if you look at it, most of the waterfallish projects or even agile projects I know of has silos between various teams. So say we have a development team, we have a testing team, and we have an IT operations team, and there could be other ones as well. So say we could have a hardware infrastructure team, or we could have many other teams, the database folks. So all these are silos, and what happens when you have silos is you do a piece of work, you take it and you'll have to hand it over to some other team, wait for them to finish something, and then it goes on and on. So because of these handovers and the process involved, there are delays in getting a software to production. So what DevOps proposes is bringing them all together and eliminating the silos with the help of a culture. So the culture should be in a way that everyone in the team should realize that they are a cross-functional team. When I say cross-functional, so you may have a team which is owning a piece of software in production, and the team would contain someone from ops, someone from database. It could contain embedded quality engineers or test engineers. It'll contain a few developers. It'll contain a product owner. So basically, the requirements from the customer arrives to the product owner, and from that point, the idea is turned into a software and it's delivered to production, and that too as fast as possible. So. So this is the whole concept of DevOps, and how it's achieved is with the help of automation. Automation is another key pillar of DevOps.
I would like to ask one question about different teams. You mentioned about different teams, right? Uh, Now, I mean, in the recent times, DevOps is used interchangeably with infrastructure teams. Is it just the job of infrastructure teams to implement DevOps, or as a whole, it has to be implemented or adopted across the company?
So that's where I think, as I mentioned, DevOps is a complex one, and there is no universally accepted definition of DevOps. So there are a lot of leaders, say Jess Humble and Allspa, and there are quite a few people who has written really good books on DevOps. But what as large organizations does is they try to adopt a part of it, and the biggest anti-pattern I see is teams trying to have a DevOps engineer, and that's it. So I think that's the biggest anti-pattern a lot of organizations are trying to adopt as well. So they have a group of people called DevOps engineers, and they think
Yeah.
we are doing DevOps, but that should not be the case. So based on what I've seen, and based on what I've read, so there are some really good books that I would like to recommend to the audience. So one of them is the Phoenix Project. It's one of the best books that you would ever read on understanding DevOps. It's not a purely technical book. What it has done is it has taken a story say what happens in a actual company and its IT division, and what are the challenges that it's facing because of the various issues in the IT process. And then the book actually explains how transformation happened over there, how the DevOps transformation happened over there, and how it actually helped the business as well. So all of us, we know we are working in IT for a certain client or for a certain company, and IT should actually support business. It should not be the other way around. So we should actually make sure whatever we do delivers value, and it should be customer centric. And that's what it explains. The book actually really impressed me when I read it a few years ago. It was
Yeah.
mind blowing in one word.
Yeah, I mean, I first got introduced to this series of books only through you. I think you had put up a LinkedIn post about the Phoenix project. I think you had said you finished reading it and you really liked it. That's when I got to know and I started the Phoenix project. I finished the DevOps handbook. Then I went back to the goal, and now I'm reading the Unicorn project. So I'm thoroughly enjoying all of them. As you said, they're really good books to understand how uh, DevOps transformation should be done, and not what is currently uh, understood about DevOps, or how half-heartedly it is being implemented uh, in the current state, current organizations, right?
Yeah, true. Yeah, I think the other books that you mentioned, they are one of the best ones as well. Say the DevOps Handbook and
Yeah.
even the goal, understand theory of constraints.
Yes.
I think a lot of, especially for a performance engineer, theory of constraints. Once he or she learns it, they'll realize it is applicable even in our day-to-day work.
Exactly.
So yeah,
So.
and even there's one more called Accelerate. So
Mhm.
I think that's also a really good one related to DevOps.
Yeah, so I come from a mechanical engineering background. I did my graduation in mechanical engineering. So I felt I could relate to what is being said in the goal. It all happens in a factory that produces parts, right? So I was very much
Mhm.
able to connect with that book. And again, the goal is based on the Toyota principles, right?
Yeah.
Toyota Production System, TPS. So
Yep. Yep.
yeah, my next target is to read lean production, or whatever they call it, Toyota Production System.
Yeah.
So okay, back to topic. uh, so in this all the DevOps transformation that you described earlier, what should be the general responsibilities of every team, and in particular, how should performance engineers adapt to this kind of change?
So if you look at it, the transformation to DevOps doesn't happen overnight.
Hmm.
So as I mentioned earlier, it's a cultural transformation, and everyone should understand their role is not just limited to what they used to do earlier. Say, I've seen developers who just don't want to do anything other than writing code, so they don't want
Exactly.
to think about the hardware that is required for the code that they write, or the underlying database and other related activities, or even think about the non-functional aspects. So they're okay to write a functional code which will do whatever functionality that is requested by the customer, but not even the non-functional aspects. So how does it perform in production? Are there security issues? Are there performance issues? And this is a typical developer mentality, especially when it comes to a lot of service industry folks. And it's the same with pretty much every other role that we take, because of the way I think all of us, we come from service industry background, at least most of us.
Yeah.
And what we are used to is we are used to the factory model where we are trained on something and we are said, okay, this is your role, and for a certain years you will be doing only this. So say a junior developer would have been said, okay, you will just write code. I'll give you a piece of functionality. You just write code, give it to me. And the same happens even in case of us performance engineers or performance testers. What happens is when you start your career, all you're asked to do is okay, I'll give you a business process. You write a script and give it to me, and you can take care of all the other donkey work like execution, reporting, and that's it. And there'll be someone else who'll actually take care of say all the other technical or more complex, slightly more complex aspects like doing analysis or setting up monitoring, or doing the business process gathering, say the non-functional requirements gathering and workload modeling. So all those are being done by someone else. So it's very rare that our folks at an early stage get an exposure to doing slightly more complex things and to understand the big picture of where they fit. Say this is a recurring pattern that I see in pretty much every role that we have in IT industry. So people limit themselves to, okay, so this is my role, so I'm going to do only that. But what for the key for a DevOps team is for everyone to understand where they fit in the big picture, and how they can actually try and do a little bit more. Say, for example, with the latest cloud infrastructure and stuff like Terraform, you could actually easily provision hardware just by writing a YAML file. So you just write a YAML file, and you could actually spin up an infrastructure, and with again few more automated scripts, you could actually deploy your application with just one click. So people actually can think of these additional areas as a part of their job. So instead of just thinking my job is to just write code, if they think my job is to take this piece of functionality to production, so they'll know they'll have to do few more things. So
Got
it's actually yeah, it's actually a bit of a learning curve, and this key point at that, because you'll have to be jack of all trades. So basically, you need to learn a little bit of, okay, so how does infrastructure provisioning work? How do we deploy a DB script, or so whatever the team is doing, they need to understand a little bit of all those, so that they understand how they all come together, and how can we eliminate waste in the software production process, and to reduce handovers as well. So that is where I think the biggest challenge lies. So because it's a culture transformation, and for someone to think that they're not just limited to a single dimensional role, and for them to play a slightly larger one.
Yeah. So when you said uh, we need to try to eliminate waste, right? So do you
Mhm.
think, I mean, you already said that, but do you think a lot of automation will help, performance engineers move towards, eliminating waste? Performance, not only performance engineers, every engineer. So you said automation can help smoothen the overall process of sending the
Mhm.
functionality to production. So do you think performance engineers should, I mean, at least in the current times, should they start learning automating things, and will that help them contribute and add value to the projects?
Definitely. So
Mm.
if you look at the current landscape, even projects which are not really DevOps are still trying to do some level of continuous integration and continuous deployment. So I'm not
Mm.
talking continuous delivery where we take software to production multiple times a day, or on-demand deployment to production. A lot of teams are still trying to do continuous integration and continuous deployment.
Mm.
And when I say continuous deployment, it's like, say, we write a piece of code, we check it in, and once the commit happens, the automated process kicks in, and say the unit tests are executed, and the software is built. Let's say it's a microservice, and say the microservice is built, it's packaged, and say it's containerized. With more and more organizations moving towards containerized deployments, containers actually it offers a lot of advantages as well. So I'm not going to go into that, but say for example, a Docker image is created for the software,
Mm-hmm.
and so that image can be taken and deployed readily anytime into any environment. It will contain the application code, it will contain the configurations. So what it does is it eliminates any manual error. So any room for any manual error is eliminated as long as the process is automated. So that's one of the biggest ways you can eliminate waste. So when someone has to go into a server and configure something after deployment, so one, it slows down the speed of the deployment, and two, there are room for manual errors, and three, even if you have someone as efficient as a robot, still
Mm-hmm.
you will have environments which are not in sync. So when we
Exactly.
say dev environment, test environment, and it could be staging or it could be pre-prod or whatever environment we call it after that before production. So none of them will be in sync unless you have automation in place. The
Exactly.
automation is key to have these similar environments so that whatever we test gives similar results, and we can be sure of the quality in production. So we'll be able to replicate, okay, so my functionality works here, well, it'll work well in production. So that confidence is actually provided with the help of automation.
Mm-hmm.
The same goes for testing as well. So all the automation that we spoke of helps with development and helps with the deployment of the application. But the next step is automation of all the testing related process. So not all of them. So there is still some manual work involved. Say, for example, no one can replace exploratory testing and automate it. So there are still some manual pieces involved, but if you look at it, a lot of things that can be automated should be automated. So that is where, for example, in-sprint test automation and in-sprint performance testing. So those are two key things for continuous deployment. And so what you do is generally, even when automation has evolved in our industry, where I see a lot of embedded agile automation engineers are part of Scrum teams, and they start writing automation code as and when a feature is being developed or a user story is being developed. What I see for performance is it's still considered in a kind of a mini waterfall model. So most of the
Mm-hmm.
projects and most of the friends that I have in other organizations, I see the same pattern everywhere. Say you start off your project and you focus on functional testing, and to a level, I think security testing, a lot of it can be automated and easily put in the pipeline, at least the SAST ones, not the DAST ones. And what happens to performance is until a piece of working code is ready or a working functionality is ready, performance is not involved. So it could be like 3 months down the line, 4 months down the line, or even after just before a working software is ready to be deployed to production, that's when performance testing is involved. So that is something that we could change by automating more and by shifting performance testing left as well. So shift left is one of the key principles, and say performance testing is considered a large complex process, and with a lot of manual work involved in terms of say data provisioning, or in terms of recording the script, and in terms of maintaining it, or in terms of setting up monitoring. So there are a lot of these steps involved, and so people think it's very hard to automate it, but once you start looking at it objectively, you'll realize it can be automated. And so how so you start so the moment you start getting early involvement, what you do is, instead of testing a large piece of the application, you start testing smaller pieces of the application. Say, for example, let's say an application has multiple microservices and a UI. Instead of testing everything through the UI by writing web scripts, what you could do is you could start testing the individual APIs as and when it's getting developed. So that is one level of shifting left. And the other level of shifting left is you could start doing unit level performance tests. So all these, what we'll then do is the more earlier we get involved, the faster we could actually start setting up automated scripts and putting it as a part of a CI/CD pipeline.
Yeah.
So,
So
yeah.
so shift left is basically validating your changes or your code uh, as soon as it is written, right? That I
Yeah.
mean, if we see a value stream starting from the developer getting a requirement, and the
Mhm.
next step would be he writes code. So if we move, I mean, if we see this as a value stream, so he is at the extreme left. So if we move our testing towards him or close to him, that is what we call as shift left, right?
Yeah, yeah, that's right. Yeah. So
Yeah.
we're shifting the activities that we do towards left.
Mm.
So that's one aspect of it. And the other aspect is shifting right as well. So say we are shifting some of our activities closer to production, getting a feedback and
Mm.
passing it back to the left. Whatever we do earlier, we try to pass it back over there. Say, for example, a lot of us, we performance test an application, but when it goes into production, we hardly try and check whether our performance results are similar to production performance. And
Yeah.
I think not many of us get involved in production issues debugging or production performance issues monitoring and bottleneck identification. So I think that should be a key thing to do. I think in many organizations there are still ops teams that takes care of production, and most of the times performance engineers are kept out of the loop, where only when they try and find the root cause of the issue and then fixes up, like just to rerun the tests, performance engineers involved. But
Exactly.
yeah, but what I would like to see is the shift right, where a performance engineer has access to production monitoring and will be able to see, okay, so this is the business process I created with this much volume. Does it have the same volume in production? Okay, yes, it has. Okay, so my scenario is validated. And this was my performance test results. Does it have the same result in production? Okay, yes, it works. So, or if not, if you see changes in pattern or changes in volume in production, you should be able to take the feedback from production and update your tests. So that is where the feedback loop is completed. So
Yeah.
feedback completion of feedback loop is key for all the characters involved in agile delivery or in a DevOps delivery. And I think that even performance engineers should start doing a lot of these.
Yeah. So the feedback loops that you said, it is one of the three ways discussed in the Phoenix project, right?
Yeah, yeah, that's right.
Uh,
So yeah, I think let me just give a quick overview of the three
Three
ways
ways.
of
Yeah.
Phoenix project. I think yeah.
Mm.
So if you look at it, the first one is principles of flow. So when we
Mm.
say flow, I think people should understand how work flows between various people in a team, or say, or various systems as well. So that's called systems thinking as well. So say, unlike manufacturing processes, where you can easily see how work actually flows between one team to the other. Say you want to assemble something, you'll be able to see it in a production floor by just looking at it, and you'll be able to see how the component is passed between one team to the other and assembled, and at the end of the plant, you'll have a working product. But in software, it's not always that easily visible. So only when you understand how actually work flows from left to right, that's when we'll be able to understand, okay, where are the bottlenecks, where are the constraints. So that's where you'll be able to apply the theory of constraints. And another thing is how to limit work in progress. I think that's another key item. So that's something that I say not just to developers, but to any team member. Limiting work in progress is a key item. So because the more you take to work, especially a performance engineer would understand the performance overhead of context switching. So when you have too many items and you'll have to context switch between the items, your productivity or your efficiency drops. So that is where I think limiting work in progress and trying to focus on one item at a time, finishing it off and moving on to the next item, it actually helps improve flow. And and third one is, I think it's reducing batch sizes. I think this again comes back to moving away from waterfallish development to agile and DevOps related flow. So how it works is, instead of trying to deliver a big functionality to production after developing for a few weeks or a few months, what you try to do is you try to develop a small functionality and try to take it to production as soon as possible. So working in small batches, and how it helps is, when you have an issue in production, you would know something that got deployed most recently would be the uh, one that caused the issue. Say, the bigger your deployment is, the harder it is for you to identify what's the issue. So
Exactly.
when you start reducing batch sizes, it actually, one, you are able to take features to customer faster, and two, you're able to catch your issues, and you're able to easily isolate the cause of any issues that you may see, and it's very easy to roll back as well. So there are multiple advantages for reducing batch sizes. And say reducing handoffs between teams. When you have cross-functional teams, you work as a team and everyone understands what they need to do to deliver that software to production in one go. It's not like every team will have its own agenda. There won't be multiple teams involved in delivering the software to production. So that is where reducing handoff between teams and having a cross-functional team helps. And the final one is identifying and removing waste. So that's again, once we understand how work flows through the team, and who are the various actors involved, and where are we spending most time, it's very easy to identify and eliminate bottlenecks. It could be environments, it could be the architecture, tightly coupled architecture, or it could be a lot of manual work. So once we understand where we spend a lot of time, it's very easy to actually identify the waste, and eliminate it, say with the help of automation or with the help of rewriting a process. So that is again a key thing in the first way, which is the principles of flow.
Hmm. And one common theme across all of these books is improving daily work, right? So,
Right.
in
Yeah.
the hurry burry of the everyday work, we tend to forget, we carry forward a lot of technical debt. We forget to improve things, and it reaches a point where it's very hard to fix them, right? So, I have seen that a common theme across all of these books is that they very much stress improving day-to-day work. So I think
Mm.
uh, as engineers we need to focus on that as well.
True. Yeah. I think not just day-to-day work, even as a personal one. I think we
Exactly.
can look at how can we keep learning continuously, and how can we keep improving continuously. So continuous learning and continuous improvement is the key to evolve continuously. I think so. That's the third way, principles of continuous learning,
Mm.
and the second way is actually principles of feedback. So what I mentioned earlier, if you look at it, fast feedback and constant feedback throughout the life cycle. So I think one of the main underlying themes of Agile and DevOps is fail fast. So I think one of the key things that in Indian mentality is you shouldn't fail. So you try and build a lot of process, you would try and do a lot of things, but rather what these DevOps principles is suggest is fail fast. So if you want to do something, try it out, and if it fails, you learn from it and you try and improve what you did. So the more you try to think of, okay, so I should make this fail safe, I should make it foolproof, you will spend a lot of time and a lot of effort in taking something to market. Rather, if you have an idea and if you want to experiment it, let's experiment it quickly. Let's fail fast. The fail fast principle applies for even as performance engineers. When we want to do, when we see, okay, so we have a gap and we want to do a POC, let's quickly pick up a tool, write a few lines of code, do a POC, and see whether it fits a purpose, and quickly do an evaluation. So a lot of I've been interviewing a lot of people over the last few years for various roles in my organization from various vendors. And one thing that I see is the hesitance to adopt new tools and to try out new things. So
Yeah,
people are uh, hesitant to fail, and what it then makes them is hesitant to adopt new things as well. So they become change resistant. So a lot of people I know are happy to stick with load runner, happy to stick with the protocols they know, instead of trying to learn and fail and help them improve. So
exactly.
that's something I think very key for performance engineer. One of the reasons that I say this is I, during my younger stages of the career, I had a chance to work on so many things. I failed on so many of those items. Say, once I ran a performance test in production. So
Hmm.
the config file was not set up properly. And once I ran a performance test in production and then I brought it down.
Oh,
So, there are such issues. And until you learn and until you improve yourself, you'll never become a better individual, or you'll never become a better person.
exactly.
So yeah, uh, so that comes back to the second way, which is a principle of feedback. So
Hmm.
until you fail and you take the feedback, or until you continuously learn and evolve, so it's not going to help you improve.
Yeah.
Okay, so now that I've spoken of the three ways of the Phoenix project, so let me just give a quick overview of how it can be applied for performance testing and performance engineering process and practices that we follow.
Sure.
Uh, Okay, so so first let me tell you the key difference between a performance tester and a performance engineer. So I see a lot of people actually throw those words around without understanding the key meaning of it. A lot of people think they are performance engineers just because they are involved in performance monitoring, or just because they are involved in writing some level of automation to do the performance tests, but that's not the case. I love Mark Tomlinson's quote on a performance engineer.
Hmm.
You're not a performance engineer until you're able to influence code before it's written.
Hmm.
So so until you try and get into the architecture decisions with solution architects or technical architects, or until you try to get into discussions with the developer before a user story is written and ask him questions of, okay, so how do you think the performance is going to be for this piece of code? How are you planning to implement it? Okay, is there a way to implement it better? So this is where I think you become a performance engineer. So inspection is too late. When you start testing something, by then it means most of the development is already completed, and it's hard to change. So what we should try and be is we'll have to engineer performance into the system. So we'll have to build performance into the system. So that is when we'll become a true performance engineer and not just test performance into a system. So I think that's where I think the first principle, which is understanding the flow, is important. Once we understand how work passes through the software development lifecycle, we know where we'll fit in. So, say, how does the functionality enters a backlog as a feature or a user story or an epic, and
Hmm.
once it enters there, how does it starts taking shape? So, say, what is the technical architecture? What is the solution architecture? Who is going to develop this, and how are we planning to implement it? And what is the architecture, or what is the hardware on which we are going to deploy it? and what is the sizing of that. So it's about asking all these questions upfront before something is built or before something is ready, and then get involved early. So test early, test often would then become a key practice. So it's about having those what if architecture discussions. It's about having those early discussions with all the stakeholders, and this just doesn't mean all the technical stuff that I mentioned. It also means having discussions with the product owner, having discussions with the customer themselves to understand what are the key non-functional aspects that they would like to have. How fast would they like the system to be, and for how many users would they like it to cater, and so all those things. And once you understand all these, that's when I think you'll be able to do a better job of either engineering performance into the system or even testing performance into the system. So,
Yes.
so understanding the flow of the work in a software development lifecycle, I think that's applicable for us as well. So once you have a better understanding, you would know where are the touch points where you can influence to improve performance. And second one is feedback. So again, so both shift left and shift right. So the earlier you start performance testing, say for example unit level performance tests or component level performance tests with the help of testing in isolation. So people, when I have discussions with performance testers, I ask simple questions. So how early can you start testing an application? Some of them, they say they can test only when the UI is ready, and some of
Mm.
them they say when the API is ready with all the other backend systems or upstream or downstream systems. So that should not be the case. You should think about, okay, how can I test a component in isolation? So say if you have an API which talks to a database is not yet ready. Okay, if you have an API which talks to a JMS component and JMS component is not yet ready, what you should look at doing is how can I include service virtualization? So how
Yeah.
can I mock those other upstream or downstream components so that I can test the performance of my component alone in isolation? So that will help you test early and give feedback early. So that comes back to the second way of thinking where we can give feedback as early as possible.
Yes.
And the third one is continuous learning and continuous improvement. So this is where I think whatever we do, we'll have to try and keep a retro somehow. So either you can do it mentally, or you can have a process and look at how can we improve things. So when you have issues in production, when so there is no way we can make sure it's 100% performant before it goes to production. So
Yeah.
it's impossible to make sure the software doesn't fail in production. So, inevitably it will fail. So it's about how we react and how we take those learnings and how we improve what we do. So that is where I think uh, if we have a failure in production, or if we find issues later in the software development lifecycle, it's about learning, okay, what went wrong. Okay, so this could have been avoided if I had a discussion with the architect about the right understanding, or this could have been avoided if I had ran endurance test as well. So not just stress test in a load test, but this was caused by a memory leak. So I could have run an endurance test. So it's about uh, understanding what went wrong and improving yourself and improving the processes that you do in terms of performance testing. And that is how you learn and improve yourself.
Yeah, so we spoke about failing fast, right? So I think
Mhm.
most of the fear people have is because if something fails, they'll be blamed for the failure, and especially so if it is a if something breaks in production, right? So I've read about blameless postmortems in these books. So that is a nice way of bringing out what went wrong without blaming anyone, right? So I think that should be practiced more often in our organizations.
True. Yeah, I think a lot of times what we see is To be honest, when something goes wrong in production, most of the times the blame doesn't come back to the performance engineer.
Hmm.
So because they're hardly involved in the post production
Production.
details.
Yeah.
So it's so only in smaller product companies, when they do postmortems, performance engineer could be involved and questions would be asked. But in such large organizations, I hardly find that happening. So this is where, again, making the point of getting involved, not just shift left and early involvement, but also shift right, and looking into what's happening in production and helping with production performance monitoring, setting up the production performance monitoring tools as well. So be it Prometheus or any APM tool like Dynatrace or AppDynamics. So helping with production monitoring will, again, it will be a learning curve, and it will help improve the performance monitoring of lower environments. You would understand what are the key performance indicators for your application, and you'll be able to take it back to your lower environments and help improve the way you monitor your tests.
Exactly. So Mohan, given that we spoke so much about what is currently happening and what we think should improve, so let's say you have the power to change one thing in the current state of affairs in software projects across the industry. What would you change?
Okay, that's a trick one. So if, if I could change one thing for a performance tester or an engineer, yeah, maybe I can pick one. For across all of the industry, across all the roles. Mm, okay. Yeah, I would say, going back to the earlier statements I made, it's not about limiting yourself to a one-dimensional role.
Mm,
So everyone should actually become, try and become cross-functional folks. So you should try and learn all the adjacent areas, and actually you should become a better individual who can contribute to the whole process and not just good at one part of the process.
so Mohan, what's some career advice you would like to give newbie performance engineers?
Okay. I think apart from the earlier ones that I've touched, like fail fast, don't be afraid of failures, and don't limit yourself to just say scripting and execution, and then try to evolve into a bigger one. Try to understand the big picture. So there are other things as well. So one of the biggest things is mindset change. So culture and mindset. I keep talking about this to folks. Uh, because that's what helps us to pick up other things. So unless you change from a limited mindset to growth mindset, you'll never be able to start adopting newer things. You will be the one limiting yourself. So that's where I think adopting a growth mindset and embracing a culture of learning, it will help improve you. It's say a lot of us, when we start a career, we are okay, focusing on, okay, so this is what my superior asked me to do. That's what I'm going to try and do. But without even understanding the context, or it's like someone in a production line, say, let's take the example of going back to physical factories or anyone. So where someone in a production line is given a part, and they'll have to assemble another part onto it and pass it on to the next line, and that's it. So that is the mentality that a lot of the junior engineers would have. Okay, I'm being asked to script, I'm being asked to record a business process, and that's what I'm going to do. But so this is where having the growth mindset of trying to understand, okay, oh, this is the actual application. So what I'm trying to do is a small part of it, and where does it fit in the big picture, and also learn to question things. Uh, I think a lot of the junior engineers don't know the basics of information gathering. If you look at it,
there is something called 5W and 1H. So which is many years ago, a good manager taught me that. So
Mm-hmm.
when you start looking into something, these 5Ws and 1H will pretty much get you the answer that you want, or that you're looking for.
Mm-hmm.
So it's the 5Ws is when, where, who, why, and what,
Mm-hmm.
and the 1H is how. So if you can just take these six questions, and if you keep applying it, you'll easily narrow it down, and or you'll easily broaden the scope, and you'll get a bigger understanding. It can be helped for both gathering information, and it also helps into bottleneck analysis or debugging. So, okay, what went wrong? Why did it go wrong? When did it happen? Where did it happen? Who did this? Or how did it happen? So it's or okay, how does this work? Where does this get executed? Which process triggers it? So it's like you could keep applying these questions with a variety of patterns, and you'll easily understand more about the system, and you'll easily understand uh, where you fit in, and the impact of the work that you do as well.
Yeah, exactly. I mean, uh, these suggestions, I think it will not only help the newbie engineers, it is of help to a lot of experienced engineers as well. So we spoke about a lot of books, right? So is there any books or blogs that you think is a must for performance engineers that they should read? Books, blogs, podcasts, anything, or people to follow on LinkedIn?
Yeah, there are quite a few. So when I started my career, it I actually did not have the uh, kind of resources that I have now back then. So I wish someone gave this to me when I started my career, and I think I would have been much more productive, and I could have done a lot of things much earlier. So say if you look at it, I think a lot of people know folks like James Pulley, Mark Tomlinson. So I think say you had mentioned that you were inspired by those
Hmm.
both, and the Perf Bites podcast
Yes, exactly.
to do, yeah, what the Perf podcast, right? So
Podcast.
so that's one of the best examples, the kind of work that they do. And so there are other folks, say Scott Bauer.
Hmm.
Nowadays, he's not as active in performance testing or performance engineering space, but when I started my career, his site, there's a site called perftestplus.com, and his site had one of the best collection of materials that I could look into for performance testing and performance engineering. I spent so many nights reading articles after articles from his site, and then similarly, Alexander Podelko. So Alexander Podelko's site has a whole bunch of material on various topics around performance, be it performance testing, performance management, performance engineering. So there are like quite a bunch of these. And there are also many others. So if you look at Scott Moore, if you look at Trevor Warren, if you look at Todd DiCapua, so Andre Bondi or Steve Souders. So there are quite a few people who are stalwarts in our industry, and just following them. I think what I always tell people that I try and mentor is the first thing to do is follow these folks on their social media profiles. So
Exactly.
LinkedIn and Twitter, just
Hmm.
try and follow them. Initially, you may not understand what they're trying to speak, but
Hmm.
over time you will familiarize yourself with the topics that they speak, and you'll get really better at okay, so these are the trends in the software industry, and these are the kind of things that the best companies and the best folks in the industry are doing. So unless you understand what is happening in the industry, you wouldn't know where you sit. So, some of the folks I know, they're so oblivious to what's happening in the industry. They think just putting a load test onto a Jenkins job is the biggest achievement. But I think that was done many years ago, and there are a lot more achievements that are happening right now. So start looking around, keep an open eye, and start following these folks. And I think you'll understand how big our industry is, and how many more things you can learn and how many more things you can achieve.
Exactly. Um, so that was a great freewheeling chat about DevOps, about industry in general, and what performance engineers need to do, to add value to their projects. So I really want to thank you, Mohan, for taking time out on a Sunday and spending time with me. I say that because you are recently married. So once again, thanks from uh, you know from all our listeners and myself. Thank you so much for coming and doing this episode with us.
No, Mrinal, I should be the one actually thanking you. So you gave me the opportunity to speak about such stuff, and actually, I think this is one of the first times I'm trying to step out of my comfort zone and do a podcast. So I've been wanting to write a blog or do a podcast or make videos, and I never got out of my comfort zone to do that.
Mm.
So thanks for giving me that opportunity, and I really enjoyed having this conversation with you, and looking forward to many more What the Proof podcasts.
Sure, pleasure is mine. Okay, that's a wrap then. So that was an awesome chat. I would like to thank our listeners for tuning in, and I hope our listeners are inspired to learn more about DevOps transformation and add value in their projects. Until the next one.